Well, Algebra 2 students, we're looking at Bell's point slope notes. I believe she had these notes here for you for number 3. I came in and did number 4, so if I could help you out with number 4. For problem A, what we're doing is we're just plugging in these numbers. They give you a point and they give you a slope. And so we plug those numbers into this equation right here. You may have seen this equation like back in the day, or like last year, looking like this: y minus y1, y minus y1 equals m times the quantity of x minus x1, like that. Well, and this is the same thing. This is the same. What she did is she just added the y1 to both sides so that you already got this y1 over here and you have y by itself, which I think is nice. So for A, your problem should look like this with your x value here, your slope here, your x value here, and your y here. And then you distribute that -1 in, and it should look like this, and then you just combine the 3 and the 2, and you get y equals -x plus 5. This one with the fraction, 2/3 is your slope, your x1 is 3, and your y is and this was a -3, so I believe in C. Yeah, I'm skipping down to C. So since it was minus a negative, it became +3. And then your y1 was a -5, and it's plus y1 plus a negative is just -5. That's why it looks that way. When you multiply 2/3 times 3, remember it's like this. 2/3 times 3/1. Remember doing fractions like that. These would cancel out, or you could think of it as 6/3. 6 divided by 3. 6 divided by 3 is 2. That's why this becomes 2. All right, so then we have +2 minus 5, so you get -3. And then you have B here. This is how you set up B with your slope, your x1, your y1, and just, work it out, and you get y equals 3x plus 18. Going on to number 5, you have to figure out the slope first for A. So here I am figuring out the slope for A, and the slope for B, and the slope for C, and I'm using the slope formula y2 minus y1 over x2 minus x1. Okay. Then once I figure out my slope, I'm going to plug that into this equation and I'm using the first x and the first y, so the first x and y value, the first x and y value, the first x and y value. I'm using the first one to figure it out just because they are the first ones. And you can see here where I figure all of them out. And you could pause this as I'm just kind of going through this and giving you what you need to solve these. What I did here is I grabbed the second ones because I want you to know, no matter which pair of coordinates you grab, you're going to get the same answer. Notice I got the same answer, the same formula, because they're on the same line, okay? So you'll get the same answer. It doesn't matter which pair you use. But once again, for these two, I just grabbed the first pair. I didn't do it for each one to prove. I just did, the first one, I used both the 1 and the 0 and the 2 and the 3. Here's my 2 and my 3. Here's my 1 and my 0. You see, you get the same answer no matter which pair you use. Okay? So you could, pause this and get those down and work on those by understanding. Don't just copy, just, make sure you're understanding. Do a little reverse engineering there and try to figure out, follow those steps in that formula. Okay, number 6 asks you to do some things. Think about number 6 on your own. Go ahead and make mistakes if you need to. We learn from them. Number 7, we have Catherine and her friends are going canoeing. The canoe rental fee is $20 plus $10 per hour. So, I'm already thinking here, and actually that's part A, write the linear equation to represent the cost of Catherine's canoe trip. So it's going to be, no matter what, it's going to be $20. So that's my y-intercept. but it's going to be $10 times every hour. So I have y equals 10x plus 20. And then how much is it going to be for 4-hour rental? Well, you just plug a 4 in there. And so you have 10 times 4 is 40 plus the 20, and you get, it's going to be $60. Okay, hope this helps you guys, and good luck with solving the rest.